Hi, Assalamualaikum and a very good morning. So now we're going to do tutorial discussion for chapter 6, focusing on the subtopic of 6.3, which is chemical properties of benzene and its derivative. We're going to focus on the tutorial question 1, tutorial question 2, 3, 5, and 6 respectively. Without any further ado, let us start. So for tutorial question 1, we have to draw the structural formulae of a compound P to T in the following reaction. So for it, we were given a benzene, and this is going to be reacting with the halogen of the ClCl molecule. And this happened with the presence of the Lewis acid. So you know that this process is known as the halogenation, where the halogenation is part of the electrophilic aromatic substitution reaction, where one of the hydrogen, any of the hydrogen in the benzene ring gonna be replaced with the Cl. Okay, so that's the idea. So we're gonna throw it again, the benzene, and then let's say I'm gonna change this hydrogen into Cl. Okay, so this is known as the halogenation reaction, and this is my product that will form. So I'm gonna label it as P. Okay, now for B, I have my benzene, and now it is reacting with the bromo cyclopentane. So you can look the big group here as R, which refers to the alkyl group. Okay, so R tadi refer kepada cyclopentane. So R is alkyl group, so it can be CH2, it can be CH3Br, CH3, CH2Br, and so on. So in this case, R refer to cyclopentane. So this is known as the Friedel-Crafts alkylation. Okay, alkylation because it enters an alkyl group. So as usual, it will undergo electrophilic aromatic substitution, where the H here gonna be replaced by an alkyl group. Okay, so the idea is that you can draw the benzene ring and attach with R. Okay, where our R here is a cyclopentane. So you're gonna draw it cyclopentane. Okay, so check the carbon 1, 2, 3, 4, 5. So this is the cyclopentane here, which refers to the R group. And you're gonna label the compound here, which is Q. Okay. Now for question 1C, we have our benzene, and then you're gonna react it with the concentrated H2HNO3, which is the nitric acid, and the H2SO4 at 50 to 55 degrees Celsius. So you know that this reaction here will provide NO2 plus, where this is going to be forming an electrophile. So one of the H here going to be replaced by the NO2 group here. So they're going to be a mechanism for this, but if they were asking for the product, you can change the H here with NO2. So what you're going to get is a benzene ring, and the hydrogen here you change it with NO2. So this process here is known as nitration. Pasal kita menambahkan nitro group. So it's going to be nitration. Now for question 1D, there going to be an ethyl benzene, okay, ethyl group attached with the benzene, and it's going to go oxidation with the KMnO4 at acidic condition at high temperature. So oxidation will not happen inside the ring. It will happen at this side chain here. Okay, dia hanya berlaku di luar benzene ring. So regardless of the length of the carbon, only one product is formed. So tak kisahlah macam mana carbon chain itu sekalipun, bila dia menjalankan oxidation with KMnO4 at high temperature and acidic condition, this going to be oxidized to form carboxylic acid. Okay, so you're going to draw the structure again, and this going to forming a carboxylic acid. So you can draw it like this, or you can draw it as COOH, where this refers to the benzoic acid. Okay, acid carboxyl group attached with a benzene, and it's going to be forming a benzoic acid. And you need to label it as S. This structure above here, you label it as R. Okay. Now for step E, you have a benzene and you will have a acyl chloride here. So if you were to draw the structure, you're going to have CH3, CH2, and you're going to be attached with the carbon here, going to be attached with C double bond O, Cl. Okay, so it happens with a Lewis acid here. So what really happened here was it will undergo Friedel-Crafts acylation. Okay, tadi alkylation yang mana kita tambah alkyl group. Sekarang acylation where we combine C double bond O with the alkyl group here. Okay, so semua ini sekali akan disubstitutekan ke dalam benzene ring menggantikan hydrogen tadi. So the benzene ring gonna be attached with C double bond O, CH2 and CH3. Okay, and these are the acyl group. Okay, ada beza dia. Alkyl without the carbon-carbon double bond. Acyl with the carbon double bond with oxygen. Alright, so this is going to produce the compound T here. Alright, so that's all for question number 1. For question number 3, we have to suggest a chemical test in order to differentiate the following pairs. First, we're gonna differentiate between the cyclohexene and benzene. Okay, so first we need to draw the structure. Cyclohexene, it will have 6 carbon chain in the cyclic, but only one of them is a carbon double bond. For benzene, you're gonna have 6 carbon in the cyclic, but you will have 3 carbon double bond. Okay, so sekarang kita nak buat chemical test untuk membanding bezakan. Boleh tak kita tentukan benzene dan boleh tak kita tentukan cyclohexene? Okay, so we're going to do the test in between these two compound here. So in order for us to note the differences, okay, apa yang kita boleh buat adalah kita menjalankan unsaturation test. Okay, so first what I can do is I can try to react my cyclohexene with bromine under the inert solvent. So what I'm going to get here is an addition reaction of bromine where Br and Br here going to be attached and the carbon-carbon double bond will be diminished. So as a result, you can say that the bromine, which is initially reddish brown in color, will become decolorized or turns colorless. Pasal bromine molecule tadi telah terpecah dan terattach di carbon Br di sini. Alright. However, when I repeat the same experiment, which is using bromine molecule in the inert solvent, which is tetrachloromethane here, there will be no observable changes. So the observation that I can say here is that the reddish brown solution of bromine remains unchanged. Maksudnya tiada tindak balas terhadap bromine. So kalau dalam lab, if the reddish brown color is still colorized, you know that it is an alkene. If it is not colorized, then you know that it is a benzene. Okay, so this situation here is the thing that I already mentioned in your lecture slide. Yang mana I have talked about benzene, it will not undergo addition reaction with bromine, it will not undergo oxidation kerana it will need to be, the benzene need to maintain the pi electron delocalization. So the pi electron delocalization will provide stability to the benzene ring, and that is why it will not undergo addition or oxidation reaction. Okay, apa yang dia lalui adalah substitution reaction, which is electrophilic aromatic substitution. So this is from your lecture 6.2. Okay, now we go to question 3b. So for question 3b, you need to compare between toluene and benzene. So first thing first, you need to be able to draw the structure. So for toluene, okay, Toluene is a benzene ring attached with a CH3. So this structure here is known as toluene. However, for benzene, it's only have the ring here. So in order to differentiate between toluene and benzene in lab, what we can do is we're going to do a test with KMnO4. So for toluene, it can undergo oxidation in order to form a benzoic acid here. As mentioned, the oxidation only occurs at the side chain of the benzene. Hanya berlaku di luar benzene tersebut. Yang mana bila ada benzoic hydrogen, okay, so bila ada hydrogen yang attach ke sini, benzyl hydrogen, it can undergo oxidation to form carboxylic acid. Okay, carboxyl group here, and the whole name of the structure is known as benzoic acid. Okay, however, and the observation that we can get is the purple solution of KMnO4, which is initially purple in color, but when we undergo oxidation, it will turn colorless or decolorize. However, when I repeat the experiment using benzene with KMnO4, there will be no observable changes. Maksudnya tiada tindak balas yang berlaku. So I can say that the purple solution of KMnO4 remains unchanged. And as what I've mentioned, the benzene ring will not undergo oxidation because of the stability of the benzene. So dia tak naklah bila dia undergo oxidation, dia tidak stabil. Alright. So now we're going to do tutorial question 3. So for tutorial question 3, we're going to start from benzene, and we need to outline a synthesis of 1-phenyl ethanol. Okay, so our starting material going to be benzene, and what we're going to produce is phenyl ethanol. Okay, so first you need to be able to draw ethanol, where ethanol will have 2 carbon, and one of it will have a functional group of hydroxyl group here. So you're going to attach it with hydrogen, and here going to be hydrogen. Okay, and this is going to get the carbon number 1, and this is going to be the carbon number 2. And the phenyl group going to be attached at carbon number 1. So here going to be attaching with the phenyl group. Yang mana phenyl group tadi will have a substituent formula of C6H5, which is referred to this thing. So from benzene, you need to produce 1-phenyl ethanol. So you need to be able to draw the structure. This is important. If your structure is wrong, your synthesis going to be wrong. Okay. So now you know the starting material and you know your product. So they can undergo a series of steps. So they can undergo many reactions. So what I'm going to do first is I'm going to draw my benzene again because I need to start from benzene, and I will do a Friedel-Crafts alkylation, okay, with the chloroethane, yang mana my chloroethane going to be attached with the CH3 at the benzene site here. Okay, so it will undergo Friedel-Crafts alkylation in order to produce CH3 here. So the reason we do that is so that we will have the same amount of carbon group here. So it needs 2, 1 and 2. So I'm going to attach it with 1 and 2 here. Now I will undergo halogenation at the alkyl site here, not at the benzene, tapi berlaku dekat alkyl chain here kat sini with the presence of UV. Okay, so it will undergo free radical substitution where one of the hydrogen at this carbon, if I want to expand the structure here, one of the hydrogen here going to be replaced with chlorine. Okay, and I choose this hydrogen here because this is going to be forming my major product. Hydrogen di sini boleh juga diambil oleh chlorine, tetapi this is our minor product. So I will take the major product where I take the hydrogen from this carbon. Okay, from this carbon. H2 become H dengan Cl. Okay, now when I have CHCl, CH3, so you can also expand the structure. Benzene. So now you have your C, H, CH3, and Cl. So what you need is OH kat sini. Okay, so you need to replace Cl with OH so that you can get to your product. So what you're going to do is you're going to react with sodium hydroxide. So sodium hydroxide here going to provide a strong nucleophile. Okay, so the strong nucleophile here will attack this carbon and will remove Cl as the leaving group. So for this, you're going to learn this in the next chapter, which is chapter 7, which refers to the nucleophilic substitution reaction. And it refers to SN2 because it's a bimolecular substitution reaction. So what happened here is that your benzene, which attached with a CH and CH3 here, yang Cl tadi akan keluar dan OH akan masuk. And you're gonna get to your product that you want to form initially. Okay, so you can draw it in the expanded structure or you can draw it in the condensed structure here. Okay, now you're gonna do question 3b, which is nitrobenzene. The same thing, starting from benzene, you're gonna produce nitrobenzene, NO2. Okay, for this case, it is easy because it is almost similar to what you have learned in lecture because you can just directly substitute NO2 with the hydrogen on the side here. So it will undergo nitration reaction, where from benzene, you're going to react with the concentrated HNO3, which is the nitric acid, react it with the Lewis acid, which is the concentrated H2SO4 at 50 degree to 55 degrees Celsius. And as a result, the hydrogen here is replaced with NO2. And this is how you can get your nitrobenzene. Okay, and as mentioned, the reactant need to be placed on the left hand side, bukannya di atas arrow. Alright. Now we're going to do tutorial question 5. So for tutorial question 5, we need to show how each of the following compound can be prepared from the toluene. So toluene will have the structure of benzene ring with CH3. Okay, so you need to be able to draw the toluene. And from toluene, for question A, you need to change it into benzoic acid. So benzene ring, and you need to produce benzoic acid. Okay, so how can you do that? Okay, the idea is simple. You can undergo, this is your toluene. So the toluene can undergo oxidation reaction with the KMnO4. So the reactant put on the reactant side, and the condition you put above the arrow, which is at acidic condition at high temperature. And what you're going to do is you're going to change the CH3 here into a COOH, where it undergo oxidation, and this will change the CH3 into a carboxyl group, where it changed the class of the compound to be benzoic acid. Okay, now for B, we have to show how toluene. Okay, this one is for A. Now for B, I need to change my toluene into benzyl chloride. So the meaning of benzyl chloride is that you're going to have CH2, but one of the hydrogen here going to be substituted with chlorine, akan digantikan dengan chlorine. So it's going to be CH2Cl. So what you can do is they can undergo free radical substitution with the chlorine molecule with UV. Okay, so which is toluene, reacting with the chlorine molecule. And the UV here is compulsory because the UV here going to provide energy for the homolytic cleavage to occur, and this will undergo free radical substitution as what you have learned in the alkene chapter. Okay, so one of the hydrogen going to be replaced by chlorine, and this going to produce our benzyl chloride. Dan ini adalah benzene. So from benzene nak produce benzyl chloride, we use chlorine and UV. Okay. Now for tutorial question 6, we have to draw the structural formula of compound A to F in the following reaction scheme. So benzene reacting with bromine and FeBr3, it will undergo the process of halogenation, where one of the hydrogen here going to be replaced by Br. So this is known as the halogenation. Okay, ensure that you draw this compound and then label it with A. For B, the similar step as before, where this is the process of nitration, in which one of the hydrogen gonna be replaced with NO2. Okay, so you're gonna draw the structure here, and you need to label it as B. Okay, for C, this structure here refers to the acyl chloride, CH3. Okay, so what we're going to do is we're going to replace one hydrogen of the benzene ring. Kita gantikan dia dengan C double bond O, CH3. So we're going to enter this side only. So this is known as acyl, and the process here is known as Friedel-Crafts acylation. Okay, so we're going to draw the structure again, which is the benzene ring, and we're going to attach with the acyl group, which is the CH3. The Cl is not included. Okay, so you can draw it as C double bond O CH3, or if you want to draw it as a condensed structure, it is also okay. Now for D, the benzene here gonna react with the haloalkane alkyl halide, which is the CH3Cl. So what we're gonna substitute is the alkyl group. Okay, so what we're going to substitute is the alkyl group, which is the CH3 here. So hydrogen going to be replaced with CH3. So yang masuk adalah alkyl group. So this process is known as the Friedel-Crafts alkylation. Tadi adalah acylation pasal dia ada C double bond O. But now we only refers to the alkyl group. So benzene ring attached with the alkyl group, which is CH3Cl. So hanya CH3 yang akan masuk. And now for compound D that we have drawn, it will undergo oxidation with KMnO4. So as mentioned, the oxidation will not occur on the benzene ring. It will occur on the side chain of the benzene. So the alkyl group going to be changed into benzoic acid. Alright, and label it as E. Okay, and for your reference, tak kisahlah sepanjang mana pun the carbon chain, the product of oxidation sentiasa C double bond OOH. So it's going to be producing benzoic acid no matter what. Alright, now in order to produce F, we have the same structure here, which is the toluene, CH3 and benzene ring. So one of the hydrogen gonna be substituted with the chlorine molecule under UV, and this will undergo free radical substitution. So what you're going to produce is the benzene ring, and then CH2Cl. Okay, initially it's going to be CH3, but one of the hydrogen going to be replaced with Cl. Alright, So this undergo free radical substitution with the presence of UV. Okay, and label it as F. So I think that's all for today's video. See you again some other time. Bye.